Hello and welcome to another tutorial. In this video I'm going to show you how to calculate the fastest way to select a destination from the user by using NavMesh from Unity, and to guide the user to his destination by, for example, this line and an arrow. Here you see the editor in the simulation mode. Of course, when I would be walking in the real life, this won't be shown, this mesh, and it will occlude the rest like you see here. This is just to show you how it's done without being there. And it is also possible to use the A* pathfinding project, which is also available for Unity, but you have to pay something. And what we actually need is a dynamic NavMesh which can move around, and by using the NavMesh components from Unity, which is an extension to the normal NavMesh, we can also do that, which is pretty cool. Then let's jump right in about the localization, finding the current position. With multiple area targets here in the scene, it's I pulled them a bit out of each other. Of course, they should be as close to each other as possible. With multiple area targets, we need to use the world center mode device. You can find this at the AR camera Vuforia behavior script here, and we just need to use this with device for multiple area targets. If you only have one, I think you can also use first target, specific target. Then maximum in your application you can have 255 area targets. At least that was half a year ago. I don't know if with the new Vuforia update 9.88 this is possible. And a Vuforia developer recommended me to only activate 2 to 3 area targets at a time. So that means in 2 to 3 are active and can be recognized, but only one can be localized. I hope that this makes sense. So you can only have one area target where you currently really matching the stuff, but in 2 to 3 area targets it is looking for the correct area target. This means, of course, that the area targets that you have, if you have more than 2 or 3, you need to activate them on the run. There was a bug in Vuforia 9.64, which we are still running on because I fear breaking changes when updating. So I'll wait until the videos are done. In the editor, we were able only to use one area target at a time, because otherwise it would just crash. With the world center mode device, the area targets recognized at the position will be moved around in the scene. So to give you an example, if I start the AR session here, this means then the Vuforia engine is initialized. In the beginning, this happens at the start of the app. It asks the user for permission to allow access on the camera. This is when the Vuforia Engine is initialized. You can also do this later in the application, for example during onboarding, or actually then when the user really starts to use the AR. And there where it starts, this is where the AR session is started, and there is the point 0 in your Unity scene. And for example, if point 0 is here, and then this garbage bin is recognized, for example here, then let me find this right thing. Then this would move over here, of course also with rotation, and this will update the whole time, just to give you an idea how this works in the scene. Then there are different challenges for how to cope with the different units used during navigation, how to find the position in this this unit. For example, for the building, we do it by area selection, and an extension or an improvement would be that you also find out the building by GPS, by using GPS signal. Then the floor, we also do it by UI selection and collider trigger, and an extension will be a QR code. For example, a user opens up the app and you ask them, hey, please go on the floor next to the elevator, there's a QR code, and then you scan it, and then in the app you know on which floor the user is, and you enable those area targets. Then the position in an area target is of course handled by Vuforia within this point cloud. And with very hard surroundings, we didn't have time to do this. For example, if you have multiple floors, and often between the floors, areas are very similar. For example, corridors, for example. And our temporary solution was to just activate the area targets of one floor, which also helps with the performance to find the position faster. And in addition would be additional markers, maybe big identical images that you also use as marker in the scene, which can be done with the Vuforia Engine. Now let's come to the navigation, the real fun stuff in the whole app, how to guide the user to a destination. We have different challenges to solve for the navigation. We have to position the air content correctly, we have to do the route calculation, guiding the user. There has to be a good occlusion, otherwise people will walk into walls. We had 20 people for user tests, and there were people really following the line, and in the beginning the occlusion was not optimized very well, so yeah, it was funny. And of course it has to be user friendly. For the position of the air content, this is done by the Vuforia Area Target. For multiple area targets it's a bit more complicated, but we will cover this more in a later video. Then the route calculation is done with the NavMesh and the NavMeshAgent. To guide the user, we use a line render and a 3D and a 2D arrow. The occlusion is done with the Vuforia Area Target mesh and can also be optimized with additional objects. We'll cover the occlusion also in a later video. The friendliness is improved also by UI and onboarding elements, which helps the user to get acquainted with the AR app, because not every user is used to AR yet. And we found out during user tests that it's very important to also warn about the obstacles in real life. For example, where the path goes a bit down, or there is stuff around that you know that the user could walk into, because yeah, that happens. Like I said, we use the navigation system of Unity to calculate the fastest route. We ended up using one NavMesh per building, just to keep it really simple. That when you optimize the whole NavMesh and scene for one building, you can bake and you have one NavMesh. And we use, like I said before, we use the NavMesh components to that the NavMesh can move around. To be able to calculate the route from the AR camera to the destination, the NavMeshAgent has always to be under the AR camera. And then we do the route calculation from the agent to the destination, which should also be somewhere on the NavMesh, of course. Then there are different things that you have to consider by when preparing the NavMesh for the navigation. You also, of course, import the area target. Then you put the NavMesh surface script on a new game object, and this game object has to be child of the localized area target. Then with the NavMesh Obstacles, you can optimize how the calculated line is shown. For example, to obscure the edges. This can be also done, partially be done by calculating the width of the agent, but with the obstacles you can do it more custom. A developer tip to show you a lot of headaches and make it a little bit easier during debugging: show the NavMesh in the app, or at least in the developer mode. This is just by rendering the NavMesh in a color. This helps to know if everything is well aligned as you want to. Here an example about NavMesh Obstacles. Here you see without, and here you see the result with the NavMesh obstacle. The NavMesh obstacle is placed here. What do you have to do to prepare the NavMeshAgent? The agent has to be stopped, so he doesn't walk away from the AR camera, of course. Then the agent should always be under the AR camera and on the NavMesh. For this we had a little script, and this is just basically this function. We move the agent to camera X and camera Z, but we use the agent Y position because the agent tries to go on the NavMesh if he's near the NavMesh. And we also have a little hack that he stays or gets back on the NavMesh if he fell down. For example, when you walk up the stairs and you go over to the next floor, it happens sometimes that the NavMeshAgent got stuck on the bottom of the stairs because he somehow slipped, and then we don't update this position. And one way of coping with this was deactivating and activating the NavMeshAgent every second. This helps just to always get back on, because we set always the position, and then he tries to be on the NavMesh. This worked, I would say, 95% in the cases. There were some cases where it didn't work, because when he's stuck somewhere in another floor and he fell through a hole in the NavMesh, for example, then you have to maybe reset also this, the Y position. But just to save time, we didn't implement this, but this I recommend as a possible fix. Then to optimize the routes, you can play around with the agent settings. On the Pro level, you create multiple NavMesh areas with costs, so that you can play around a bit with where the user is guided depending on different situations. We didn't do that just to keep it simple. For example, in our case, we had to change the size of the agent a little bit to a smaller person, because normally the agent should represent a person walking in the scene, but with the area targets, because they're not perfectly scanned, you see, for example, here a normal person would not be able to walk here, but in the real life this is even further to the right, and it's totally possible to walk by here. So I also want my NavMesh system to be able to recognize this route. So in order to do this, we need to have the where's the NavMesh? Here's the NavMesh. You need to be able that there is a connection here, and we did this by using where is the settings? This is the inspector settings here, open agent settings, and then we had radius 0.1, which is of course very slim, and height 1 meter, so it fits right through there. that was basically just because of this situation here, because the scan was not done very nice, because this scan was done 3 years ago, and so that was not very important, I guess, that everything is very nice, but that you can look around the laboratory. And so, for example, if I change this to 0.3, I should see a change that I will not be able to walk here, which works. So you have to tweak around a little bit how it works the best for your case. You could also try to work with NavMesh links. What I wanted to show also is sometimes you end up not having a very nice transition from one area target to the other. For example, stairs is very complicated because area targets should not overlap, because then you have same points in both point clouds, which will be hard for Vuforia Engine to know in which area target you are now, and that the navigation still can continue, and also the route can be calculated correctly. We used, because here in the scene I can show you these two objects. When I move these two objects away, this was the actual scanning ending of this area target, and here starts a new one. Again, we can see this because this is this doesn't work because of this bug. And these, we added this this material, and I will try one example now, so we know this for sure. If I deactivate this, and let's deactivate this one. Let's deactivate this one. If I now do the whole NavMesh baking again, let's see what happens. This should go away, of course. Maybe I cannot even, well, maybe he can walk here, but this should definitely go away. Exactly, I would not be able to calculate the route by here. So what I do is very simple. I will just add let's just add a cube somewhere. Game object, 3D cube. Voila. Then we squeeze it a little bit. Put it here. I don't have to do it really nice now, but just so it works, more or less. Has to be around here. For example, like this. Now let's see if this works right away. Yes. Oh, what is happening? What is happening? Some key got stuck on my keyboard. Okay, so this should work with the NavMesh surface. Just to add a new object and then add it in the scene, and it is included in the NavMesh baking if it's close to the rest. And of course, if it's if the NavMeshAgent can walk on it, you have to check for the max slope, step height, etc. Then the navigation line is done by rendering the path of the NavMeshAgent. So the NavMeshAgent is always calculating the fastest line, and we just simply render this. The first position of the line, here's a typo, is always the NavMesh transform, so you always have to update this. Then the 3D error to show the direction of the line is always on the next path, on the next waypoint, and it looks to the next waypoint. This is not stable because the line of course changes, it moves around. This can be optimized, we just didn't have enough time. And there's also a 2D error to show back on the line. This is just a free Unity asset, I'll post in the description. Let me show an example. Here in the app, select English, skip the onboarding, and then I select a destination, toilet, and then in the, this is something funny from the inclusion, you will see this in another tutorial. So this is here, and here you see all the corners of this line render. Basically these are all the corners of the NavMeshAgent path. These are just always updated. You see the first one, this is from the NavMeshAgent of course, because I'm walking around, so this just change all the time. The others, they will change when we have to do a rerouting. Okay. I want to show you also the script for the air path visualizer, because this one I just copied from the internet. I reference it here. And so we use the air camera, we have the line renderer, the pin, this is for destination. Then we have the NavMesh path, we have a timer, and we have a variable to define the height above the ground, so the line is not on the ground but maybe a little bit in the air. And then we have transform A and B. A is from where do we calculate the path, and B is the destination. And then we also have utils to estimate the length of the path and also how long to go there. I won't show this in this tutorial. And then we have the next waypoint. This is used for the off-screen pointer. This is this to the arrow called, and this is the game object for the arrow. So we create a new NavMesh path on awake. Then when we are localized and there is A and B set, this is the line render. We set the first line render position to the agent transform. This is done in a setter method here, set position from and set position to. When this is the first time we set the position to, we tell Unity to calculate the path immediately because we don't want to wait for a delay. You'll see that right in a minute. And we also update the end of the destination of for the pin. And so here in every 0.0 seconds we want to recalculate the path. We don't want to do it more regularly. It needs of course lots of performance to do that. We can also do it less. By Unity it's recommended to do it every second, I think, just to keep it to not use too much performance. In our case this worked well because we didn't have too much space for the routes. If you are in a big environment and you have really long paths, and you probably should not do path calculation every 0.1 seconds, then you maybe use not the line renderer to show the route, but you create an own game object with an own with a separate, which is not always updated from the NavMesh path. Does it make sense? And so if you're localized, you also want to activate the pin, of course. If not, we deactivate everything. This command here is used that the pin rotates itself and always looks to the camera. This is not always nice. For example, here you see that is covered by this mesh here, so this part will be occluded. This can be also optimized by just rotating it on this axis. I don't remember which one it is. Then we have the draw path method. Here we pass the path, and basically this is the same as explained here in this mentioned source. When we have more than 2 corners, we continue. We set the count of the line renderer, and then we iterate through the corners of the path and set each position of the line renderer. With the transform arrow, we position the 3D arrow on the next path corner. Only if there is more than 2, but we position it on the next path corner, and then look at the next path. I'm just editing this now, and I also wanted to say that this method is not really stable, because when you are pointing to the other corner with this arrow, you probably have seen it in the demo, then it like moves around because the NavMesh agent calculates the path very frequently. Then the corners of the path, they change really fast, and then the arrow also looks a bit like shaky. This is just a really simple solution we came up with to do a really dirty fix. And there's, of course, you can do it much better, that you don't update it so much, or only update it when there's a bigger change. Yeah. So this stuff is for the next waypointer. This is this 2D arrow that is shown when you look away from the line, and it basically shows to the next arrow transform that is above the next corner. Some things to consider when doing navigation with multiple area targets. All area objects must be children of the current localized area target. At least this is our approach on how to handling multiple area targets. This is different from the method how Vuforia explained it in their documentation, because when we did this project, this explanation didn't exist yet. Someone told me on the channel that their solution doesn't work for him this way, so I didn't check out the other solution yet. Maybe I will do that to help you out, but I will explain how this multiple area target solution can be done with this idea. And then, of course, the destination must always be child of the localized area target, so it is also moved around where it's currently matched to the real life. And you have to activate and deactivate the different area targets when walking around, and this is not always very easy, but we'll show this in another video. Closing remarks. We found out how to set up NavMesh and NavMeshAgent. We do the navigation of the user with a line, an arrow, and 2D arrow. Then the videos coming up will cover the multiple area targets, activating other area targets, for example the area target door, and then the delayed Vuforia Engine initialization. This is when you want to activate the Vuforia Engine not at upstart, but maybe during onboarding, or when you really want to start the AR session. I will do a video about occlusion. I will show you the Easter egg game that we implemented and how to support the app with other languages. Some people asked if I will publish the code in the public, and because I invested more than 900 hours in this project, I will probably not do that. I will think about if I want to publish the project as a Unity asset, like as a basic starting app that you can do indoor navigation, and there will be all of the code, of course, and I hope you understand that. And still, I want to do these videos that it gives you an idea how to get started. Thank you very much for watching. I hope you learned something, and I hope that I can help out in the comments if there are any questions.